I'm Sean Gilson from Gilson Engineering, Orlando, Florida office. Welcome to the Gilson Engineering Flow Lab. Today we're going to be talking to you about TypeK damper drives. This little sample I have here is a sample damper drive that mainly we focus on replacement drives. You may have an old drive out in your plant that looks like this. An old Bailey, an old Westinghouse, Hagen, maybe a Fisher, or maybe some kind of homemade damper drive like we see every now and then. What we do is we provide you with a pedestal style damper drive, or perhaps direct mount if you would like a direct mount, that's going to drop onto your existing mounting holes, and we're going to give you an output lever that will be in the exact same X, Y, and Z dimensions as your original drive. All you'll need to do is remove your old drive. This drops right on place. Rehook your linkage. We will replace the linkage if you need to. And then all we do is hook up your plumbing and your wiring. We try and do it so that you have the minimal amount of work and you're back up and operating as quickly as possible. Let's take a look at the construction of this drive. Right here is our actuator. This is the heart of the drive. This is what gives us our power. This is a K1. We have sizes K1 through K7. This is very small and would rarely be used in a real industrial application. Our K7 is a large clamshell that's about this wide and about that wide in this dimension and provides as much as 10,000 foot-pounds of torque. Let's take a look at the inside. Typically, to take this apart, we're going to have to remove all the bolts around the outside of the enclosure. That's already been done for us to make life easy. And once we take it off, we see the heart of the actuator, the one-piece vane. This is the only moving part within the entire damper drive. This part is made of an electroless nickel-plated vane with an integral shaft. Notice that they're one integral piece. There's no way for the shaft to become decoupled from the vane because they're made from one integral piece of metal. It's an electroless nickel plating over top of an alloy steel for the best of corrosion resistance. Internally, we push air on one side or the other of the paddle to make it move. This lip seal is one of the most ingenious parts of the design of this actuator. Notice that as I push on this side, the pressure is going to help expand this lip seal, holding it tighter against the inside of the clamshell to ensure a proper seal. As I come around to the other side and I'm pushing on this side, I never get any air to push on the back side of the lip because this lip seal is now holding it firm. Also notice down along here, the lip seal covers the entire interior perimeter of the clamshell. What that means is that I do not have an O-ring up here. All we have is a little bushing. That bushing helps keep dust and dirt out. That's all it needs to do. It's not under pressure. You may have seen similar clamshell designs. Some people will put an O-ring and wrap it around the center of the vane and it comes around this way. What happens then is you push this O-ring back and forth and you have lateral forces on the O-ring which will eventually just drag it right off of that vane, and all you do is blow air back and forth. Those are the same guys that bring you the O-ring on the shaft. An O-ring lip seal along this vane is not a good design. It's certainly not the kind of design you'd want to put in on an ID or an FD fan or superheat reheat that's critical, requires high reliability and high precision. Now, speaking of precision, take a look at the vane, how if I move it just a little, this way or that, I get an immediate output in my shaft. Compare that to, say, an electric drive with gears. When you have gears, let's say my fingers are your gears as they mesh. When they're new, they're all nice and tight. When this gear moves, the other gear moves. But as these things wear through the years, and you get wear on your gears, you're going to have them widen out so that sometimes one gear moves a little bit before the other one finally catches and moves. This will be especially noticeable when you reverse directions. You push on the gear that far, and then when you turn around, this thing has to move back before it catches and meshes for you. You get a much higher precision out of a Type K pneumatic damper drive than you will out of an electric motor. The interior is also painted with our two-part epoxy powder bake finish. That gives us both interior and exterior that's going to hold up to the harshest environments. Nobody's air is all that clean, and we know that. We go in there with the dirty air in mind and put one together that's going to hold up even to the dirtiest of air. Put it all back together, you see our end stops. Internally on the paddle, we have a raised piece that will hit against the end stop when we get to that position. This is adjustable so that you can adjust your dampers out in the field. You may have seen clamshell actuators that look a little bit like this, only they're painted yellow. There are very significant differences, although the designs are very similar. Type K originally started selling damper drives with the yellow painted actuators. The differences are minor, but very, very important. Notice the size of our casting. With the yellow actuators, as we hit that end stop, we got severe breakage right along in this area. It would come over, it would hit the end stop, would get breakage here. The case would leak, the drive was completely inoperable. Internally, these pieces had plastic parts. The seals were not rated for very high temperatures. Type K has nothing but metal parts on the interior of the actuator. Again, I mentioned the alloy steel with the nickel plating. Around here, these parts are all metal. The nuts and bolts are stainless steel. We have an expander, also out of stainless steel, so that we have non-corroding, high-tech parts that are going to hold up in the highest temperature ranges. This lip seal is rated up to 212 degrees Fahrenheit. On the outside, we made the casing much bigger and beefier than the ones that are painted yellow, so that we don't experience the problems with the breakage. This casting will take up to 150 psig internally on all but the highest, the largest, the K7 size. What that means is we can deliver more torque with a smaller actuator. If you've got the ability to pump up your pressure, you can save money by buying a smaller actuator. Once we put this actuator together, we put it in on the pedestal or on a direct mount, and we customize it specific for your application.